Hello, I'm Flores. I work for the Alfred Wegener Institute in Germany. On Mosaic, I'm coordinating the zooplankton and sea ice fauna sampling. The climate crisis has caused the Arctic sea ice cover to change dramatically. If we compare the sea ice extent in 2005, 15 years ago, with the most recent minimum in 2012, we see that about half the extent of the Arctic sea ice has disappeared. And this has big consequences for the physics, the chemistry and the biochemistry of the Arctic Ocean. But it also has big consequences for the animals that live there. It may come as a surprise to many people that are not so familiar with polar environments, but the sea ice actually supports a diversity of life. We find microorganisms from small ice algae and bacteria. We find little crustaceans, we find worms, we find fantastic jellyfish, and we also find birds and mammals, up to the famous polar bear. But let's zoom a little bit into the smallest one, the microalgae. In general, in marine food webs, microalgae provide the carbon to the whole community that depends on them. And in the Arctic Ocean, there's a special case. There is microalgae that actually live inside the sea ice, and these are called ice algae. Ice algae, in certain parts of the year, especially in springtime and autumn, support significantly the food webs of the Arctic Ocean. They feed small crustaceans that in turn are the prey of fish, and these are the prey of the birds and mammals of the Arctic Ocean. So the production of ice algae is a critical aspect in the Arctic ecosystem. My colleagues and I are very interested in what happens when all the sea ice disappears in large parts of the year, and the role of these ice algae diminishes or changes significantly in the timing of when the blooms appear. I personally am interested in a fish species called the polar cod. These are very small fish, about this size, but they are very important in the Arctic ecosystem. They come in huge numbers and they are the main prey of the birds and seals of the Arctic Ocean, and thus indirectly also feed the polar bears. They themselves rely on small crustaceans and thus are really in the center of the Arctic food web. What makes them really fascinating is that they have adapted to the sea ice. They have a biochemical compound in their blood that allows them to survive freezing temperatures, so to keep the blood liquid even if the temperatures outside are at the freezing point of seawater. They also adapted their lifestyle to the presence of sea ice, and the young one especially, they like to seek shelter under the big ice floes. In 2012, we were able to sample the polar cod directly at the underside of sea ice using a specialized net. And using backtracking of satellites, we could see where the sea ice under which the polar cods were caught was actually coming from. And indeed, we could actually trace all those sea ice flow that carried polar cod back to certain areas in Siberia where we believe are spawning grounds of polar cod. So we put forward the hypothesis that these polar cod actually hitchhike with the sea ice all across the Arctic Ocean, and hence use the sea ice to distribute themselves but also to connect between different populations. And this is where mosaic comes into play, because the mosaic drift is by nature actually following about the same trajectory that we think the polar cod are also following. So we can trace the state of the ecosystem, the feeding conditions of the polar cod throughout an entire year, from the beginning of the drift to the end in the next melting season. It's especially interesting to find out what the food offer for polar cod would be, because drifting with the sea ice is not an easy thing, because as a fish you would always need a minimum energy supply from food. We know that in summer they feed on small crustaceans, and those that live under sea ice especially feed on little crustaceans called amphipods, and these are ice amphipods that are only living at the underside of sea ice and actually graze ice algae. With a biochemical technique, we could show that a lot of the carbon that is in the tissue of the polar cod can actually be traced back to the production of ice algae. In fact, it's about 50%. So this is a proof that ice algae are very important along the entire food chain of which polar cod is a part. Now, how do we sample the state of the ecosystem on a drift station such as mosaic? We sample mainly the food sources of the polar cod, which is the zooplankton and the under-ice fauna, using a variety of nets, but also echo sounders. In particular, we use a little net that is mounted on an underwater robot and that is equipped with a broom on top, so it sweeps the underside of sea ice and catches those little amphipods that the polar cod like so much. In short, sea ice is an important driver of Arctic ecosystems. It's a nursery ground for polar cod and it nourishes a long food chain. Sea ice-associated biota, a unique part of our planet's biodiversity, are at risk of disappearing forever. Mosaic will help to pinpoint bottlenecks in the food web and in the life cycles of species that are particularly vulnerable to the climate crisis. Knowing these bottlenecks will help improving predictions and mitigation measures in the future. I hope you liked it and myself look forward to finally getting on the flow.